Right, this is question 9b of the mock paper that you did recently. Again, you'll start to see a emerging pattern with some of these questions. It's initially again asking for the name of the uh, actual mechanism itself, and finally again this word, the outline. Whenever you see the word outline, it means to draw out the mechanism. Okay, for the following conversion over here, and they've sort of tried to catch you out a bit by drawing the abbreviated structures over here and here, but in order to tackle this question, what I would do is I would start off by drawing our reagents together. Initially you should be able to recognize that this is an alkene reacting with a halogen, and those types of mechanisms, or the name for those types of mechanisms where a alkene reacts with a halogen, is known as electrophilic addition. Addition because you are adding a molecule across, or a molecule across the double bond, an electrophile being a lone pair acceptor. Right, first steps first, what I suggest you do when tackling this question is draw out the molecule in full if you can, like I have done over here, and then highlight a few key areas. This area over here is a area of high electron density. It's got a lot of electrons there. Now, we know that bromine, or the bromine molecule itself, isn't polar normally. However, it can a polarization can be induced on the bromine molecule because it comes into proximity with this area of rich electron density over here. Now, we can represent this area with a slight negative charge. You remember your delta negative there? Okay. And the mechanism is going to be shown with full-headed arrows. What we have is these electrons breaking up and attacking this bromine over here. Considering that this bromine is in proximity, this one will be slightly positive because the electrons in this bond have been repelled once it's in proximity, and these electrons here, or this bromine, will be slightly negative. Okay, it's an induced dipole. Hence, this reaction can happen where the electrons can be, or this electrophile over here can accept these electrons. Okay. Now, considering that this bond is being formed, these electrons over here will go to the second bromine over here, so that bromine there now has an extra electron than what it should have. It's got 8 electrons instead of 7, that's why that bromine there will become negative. What we've formed over here now, or what we're indicating over here, is the intermediate stage. This is a carbocation because it's only forming 1, 2, 3 bonds there. Okay. Now, we also have the other bromine which had an extra electron in the mix, so to speak. Okay. And if it's got an extra electron, it's got a negative charge. Now, you've got a formal or formal positive charge on the carbocation that we formed. This is a secondary carbocation because it's attached to 2 other carbons, and you've got a negative charge on the bromine. So this bromine will now be able to attach itself here, and then you would form your molecule. Right, let's see where we get the marks for this question over here. First mark would be the naming. The second mark would be showing the double bond attacking the bromine there. Third mark is obtained over here. The fourth mark will be to show the positive, or the formal positive charge on that carbon there, and the fifth mark is for this arrow over here in a 5-mark question. Hoping at that stage, if you did not get that right in the actual mock, you have gone over your paper and had a look at where you made your mistakes.